All right, everybody, welcome. Good evening. I want to start out by thanking Tecnoglass, our sponsor, for our Tecnoglass lecture series. I know the dean normally does that, so thank you on his behalf. And they're a generous sponsor, and we appreciate being able to have these talks that bring great voices and minds here. It is critical to the culture of our students, faculty, and profession to hear outside voices from across regions, cultures, and practices, and without their sponsorship, we would not be able to do that. So as a brief note, our series is titled The Health, Safety, Welfare of Architecture. What does this mean? It means the profession defines the duty of architect in terms of health, safety, and welfare. The demands on contemporary architectural practice are stretching these responsibilities to include critical challenges such as social inequity, environmental stewardship, and climate change impacts. The 2023-2024 Tecnoglass series features practices that have meaningfully impacted the built environment by energizing disciplinary dedication with persistent innovation and imagination. They work through the pragmatic demands of health, safety, and welfare and reach with an expanded material formal capacity beyond traditional boundaries to tackle the big challenges we face today. Bringing us to today, it is my pleasure to introduce tonight Gregg Pasquarelli, FAIA, and founding principal of Shop Architects. As founding principal, he has been at the center of a collaborative and innovative practice in creating new models for design, master planning, and real estate development. Gregg has led many of the firm's most complex and dynamic projects, including in New York, the Porter House, Barclays Center, the East River Waterfront, Esplanade, Pier 17, and many, many more projects in New York and internationally. Gregg joins us this evening to share his diverse and trend-setting perspective on a healthy practice. Several of the questions our lecturer series prompt and our lecturers have discussed this year have focused on the role of the architect. Gregg has worked to expand the definition of the architect's role to include the widest possible range of actions that might impact the built environment. When they started their firm, the ambition of architecture was shrinking, and many said that the health of the profession was in doubt. Today, looking back on Shop's body of work, both architectural and process innovations, we can see how the firm has contributed to opening many productive paths forward for the practice of architecture at large. We are extremely excited to see the amazing work that serves to explore and define this initiative. Please help me welcome Gregg. Thank you.
Thank you, Shauna, very much. Thank you for having me here. You know, when they say, do you want to do a lecture in Miami in February, you're kind of like, okay, it's a lot better than New York. So happy to be here. But Shop was founded by several principals whose last names were Sharpless, Holden, Pasquerelli. But in the first year of the practice, we actually took our names off the door because we wanted to build a more open framework for how you think about architecture and how the practice would last beyond us, that it wasn't just about the founding principles. And it was a time when people really sort of were in two camps. You either like really did kind of exploratory work and you know thought about theory and radical design and pushing the limits, or you sort of knew how to put a building together that didn't leak. And people, believe it or not, 25 years ago thought that those were two different things. And from the very first moment that we came together, we felt it was equally important to be both thinkers and makers, that you couldn't do one without the other. And I think that that's the first thing that leads to a healthy practice, which is that you're not in one camp or the other, but that you're a both and firm. I think another thing is that you're not aesthetically driven, that you have to constantly ask questions about what is happening on the site, in the city, what you want the project to do, how you want it to perform, what kind of impacts it has both internally and externally, and what are the kind of relationships between those that drive the form. And so we never think about what a project's going to look like. We sit down and ask questions like this and start to think about, again, performance of the architecture, not the kind of aesthetics of it. one of the things that we found very interesting was that as we started to practice architecture, that we really realized that plans, sections, and elevations, which are the main way that we communicate as architects, are actually pretty bad tools in general. And they're bad tools. They're good tools to help you think through a project, but they're bad tools to transmit to others who actually build the buildings for you. And so from the very beginning of our office, we really started to look outside of architecture, mostly to aerospace and to the automotive industry, to think about the way that those drawings are made, those models are made, those pieces are put together and then assembled somewhere in the world. Maybe even they're made all over the world and then they're brought together at one place and how they come together. And by mastering that, we were able to push the limits of what you could do architecturally and make different kinds of translations and sort of extract every dollar out to sort of make better citizens of the buildings and the places that we make. And this goes all the way back to scarily almost 25 years ago when we won PS1's Young Architects program, but created a kind of urban beach, which was a sculpture. And this was the construction document set, which was a series of templated, large scale templated drawings that you just lined the wood up based on a color coded sequence and put it together in order to create this object that then sat in the courtyard of PS1, which is part of the Museum of Modern Art. And it was this first time when we brought together this notion of structure, surface, and program into a single element, where the walls became the chairs, became the benches, became the structure, became the chambers, and created this object that was very easy to put together, and really kind of drove this whole program for the museum. But as we continued to do projects like that, we really got deeper into the making of things and that how do we draw them? Because architects are very good at taking all of these different problems and synthesizing them into a spatial solution. And then we have to dumb it down into 2D information and give it to other people to both make the parts and to put the parts together. And that reinvention into not only 3D, but 4D and 5D is where a lot of things are lost. And so we continue to look at outside ways of transmitting this information in order to build buildings. And then the first time we were able to do that was a small park we did out on the eastern end of Long Island in a town called Greenport. And there was a folly that the mayor wanted of a camera obscura. And so we asked them if we could just take that opportunity to make the first building that was completely digitally fabricated. So it was 2,200 parts, no two were alike. Every single one was fabricated with CNC equipment. It was delivered to the site and it was put together. And the most interesting part about that was that these were the drawings that made the building. They were either drawings that told you how to make each one of the parts, or they were drawings that just showed you how to put the pieces together. And this is every part that went into making the building. And we really were sort of using a lot of this, early cutting edge technology and visualizing and thinking about how the pieces would go together. And every part was sort of pre-numbered, pre-drilled, pre-slotted, and went to the site. And we created this little pavilion, which still stands today in this park. And it was a really telling thing for us because we were able at a very sort of strict budget, able to produce a kind of piece of architecture that was able to use better materials. We were able to control where the materials came from. We could think about the supply chain, about the labor practices, and we could make everything customizable, but it was mass customizable, which therefore was a sort of more effective way of delivering things like that. And very soon after that, we did our first development project where we joint ventured in order to get a building where someone would allow us to test these ideas out, because no one had ever used CNC equipment to make a facade before, was that we had to joint venture with our client to become the developer ourselves, because then the client said, well, you have at least as much at risk as I do. And if you want to try these crazy ideas, you're going to get hurt if you screw it up. And so it was by taking on that territory of risk and finance and figuring out the project that we were able to push the limits of what we could do from an architectural perspective. And so it was basically a historic building. We put a contemporary top on. We made 22 sort of protoforms of a zinc paneling system. It was 4,000 pieces in total. It went directly from a 3D model to the plasma cutters. The 4,000 parts were made. Every part came and it explained where it would be delivered. And then there was a code system that was laser cut right into the part, which explained to you where to put the piece. So the architectural detailing of the building itself was the instruction set for putting it together. And so this was the building when it was finished. This is the first fully digitally fabricated facade in the United States. And we brought it to market and it did really well and it helped the whole neighborhood and it really pushed a lot of things that happened in this part of the city. Now, interestingly, the building that this is taken from, and this was finished in 2003, and in 2006, the building across the street was taken by a small little search engine firm at the time called Google. And Larry and Sergey's offices actually looked out on this building. And so they liked the building so much that they called us one day and they had us come in, and we've been working with Google for 18 years now doing projects, but it was just because they understood what was going on from a technological standpoint that they then invited us in to begin to think about how to plan and work and do work on their campus. That said, this was a 50,000 square foot building, which is not terribly big, although we really learned a tremendous amount about it. As we said, we were development partners on it. The project was a success. All the projects that we've been development partners on have not been successes, but this one was. And we took whatever revenue that we generated from this to help build the practice and to really reinvest in the research in order to push architecture forward. Now, crazy enough, only about 6 years later, there was a very large project that was about to happen in Brooklyn, which was eventually became called the Barclays Center, which is the NBA arena in downtown Brooklyn where the Brooklyn Nets play. And they were having trouble with the project. It had been a Frank Gehry building. The building, the crash, Frank Gehry made a really interesting design because typically arenas are not great neighbors, right? Because when there's not a game going on, it's like a dead zone all around it. And Gehry did a fascinating plan where he built 4 towers with large foundations and held the bowl of the arena in the middle so that you actually couldn't see 80% of the arena. It was buried in the base of the buildings. Fantastic idea, except for in 2008 when the crash was happening and there was no financing available for the 4 towers. So they had to redesign the building, and they went back to Frank and said, you know, how long would it take you to design a building that was a standalone building? He said 2 years, which is about right. The problem was that stadium bond financing was no longer going to be tax deductible if the foundation wasn't in by December 31st of 2009. So the project would have taken a $400 million hit and the developer would have gone bankrupt. So they had about 6 months to figure out how to redesign the whole building. They went to a design build contractor, Hunt Construction, who had done 10 NBA arenas. They said, we'll fly you around to every arena. If there's one that you like and it fits on the site in Brooklyn, we know we have the drawings and we can order the steel and you have a 50% chance of getting your foundations in, but you'll have to put another 200 million at risk. So they took the chance. They said, okay. And then they went to Mayor Bloomberg at the time and showed them what the building was going to be. And they were super upset with it because they wanted a great piece of architecture. And it was a sort of very pedestrian looking building. And so they came to us and they said, can you reposition this building, rip off everything on the outside and turn it into a piece of architecture? So that's what we did. We started working on it. And eventually it became these 2 wrapping bands of, I think it's 11,500 different panels of Corten steel. And we redesigned the building into 920 mega panels that were exactly the size of what you could put on a truck and get into New York City without a special permit. So we reverse engineered the entire project. We actually created a joint venture with the facade manufacturer. We built a warehouse and collected rainwater. We hung the produced all the fabrication tickets. We hung the panels on a dry cleaner rack that went through 15 wet dry cycles a day for 4 months and put 10 years of the rusted patina on those pieces. We wrote our own iPhone app to be able to track and manage the construction of all of these things. And here you can see going through the wet dry cycles. And the 921 panels came together and clipped in perfectly and were able to fit, and we got the building done on time. Now, the only reason they let us do that was because they looked at that little porterhouse building at 50,000 feet. And because, we had never done anything more than 50,000 feet. Now this is $1 billion project. But they said that they were shocked that we, one, took a financial position in the development of the building, that we took the risk of using these new technologies to make a new kind of facade system, and that we were completely at risk for doing that and solve the problems. And that gave them the trust to let us then do it on the $1 billion project. So this is the Barclays Center, what it looked like when it was completed. The interior, at the time, most arenas were really sort of like very colorful. They kind of looked like shopping malls or like airports. And we love sports. So we sort of wanted to make it feel like a black box theater, have it really, really dark. We use special lighting to make the court really float and be dramatic. But maybe my favorite thing that I've accomplished as an architect in 25 years was I got the New Jersey Nets to change their colors from red, white, and blue to black and white. I told them, if you want New Yorkers to wear this, it's got to be black. And I got them to pay. So I said, all the seats need to be black. We have to use black concrete. We have to paint the ceiling black. And we have to really make it feel like this black box theater. And for 2 years, they kind of just like nodded at me and thought I was crazy. And then I was in a meeting where they said, the change order to paint the ceiling, like this ceiling's painted gray, the change order to paint the ceiling black is $2 million. Like, do we really need to do this? And I said, and at the time, Jay-Z was a part owner of the Nets, and he was sitting next to me, and I said, yeah, we got to paint it black because it's got to match the uniforms. And after 2 years of them like literally ignoring me and humoring me, he said, you want to change the uniforms to black? And I said, yeah, they have to be black. And he goes, that's a pretty good idea. And they said, absolutely, we're changing the uniforms to black. So thank you, Jay. But here you can see the entry. It's the only arena built with 0 parking spots. And the whole idea was to make it, which they then said would become Carmageddon in downtown Brooklyn. But we said, if you make the experience of coming by public transportation better than coming by private transportation, you will have less of an environmental impact and people will do it. And in fact, 86% of people do arrive by public transportation. And then this led to other projects like a city-funded 2-mile waterfront underneath a highway where we reclaimed land and replanted elements and built, this is on the East River, and then built Pier 15, which has a river environmental education component and also a bar to make money to take care of it. And then all the way up to Pier 17, where we repositioned the South Street Seaport this is where ESPN broadcasts from, and Nike has their design studios, and then it has all food and beverage. And then we flattened the roof to make a concert venue on the top, which is, if you are in New York and you like the band, I highly suggest going to. It's pretty amazing to see a show up there. But we continue to always look at the sort of research, and whether it was 3-dimensional printing, whether it was taking bamboo in order to create molds for concrete or furniture or pieces. And then we did this for Art Basel and Design Miami, I think in 2016, which at the time was the largest 3D printed object, which was the entry pavilion. And then continue to research on different kinds of ideas and different materiality. So this was looking at how to take something like a traditional material like terracotta and extruding the clay through digital equipment in order to see what we could do with this traditional material to reposition it into something else. So here you could see some of the test pieces we made. And then we were invited by the Milan Furniture Fair to do a pavilion outside of that. and we created this object, again, using digitally fabricated, extruded terracotta. And it all comes apart and then it goes together. And it's called Wave Cave because 1 year it looks like a wave and you can enter it like this is the object. And then the next year you flip it over and it's a cave. And so wherever you install it, you can do it either way. And so that was a really kind of fantastic research project that then pushed us into this material that's a very traditional material, terracotta, that people wouldn't think, but really by using digital fabrication and research and these ideas, what could we do to bring this material back? Because it really has a kind of fantastic texture, and we think is doing some kind of great things for the cities where we're putting some of the buildings. And so that eventually led to us winning the Milan consulate for the State Department. So this is now under construction in Milan, reusing a historic police station, keeping all the original pieces and then creating the new building in the middle, inviting people in, even though there has to be a lot of security, but there's an art gallery and there's a cafe, and it makes people feel very welcome and it doesn't feel like a fortress. And the Wave Cave is actually going to go permanently in the gardens of the US consulate in Milan. And that's led us to other projects, like this is the new embassy in Bangkok that's under construction. This is a university building in Vietnam that we're in the planning of. Other buildings, this is the new International Center of Photography on the Lower East Side. So the building is either closed or completely opens up to the street. To our competition, the worst second place we ever got, which was for the Obama Library in Chicago. That was a tough one. But to buildings in Australia, a new tower in Rotterdam. This is a new building in Miami in Brickell that is under construction right now. This is in the Republic of Georgia, 2 95-story buildings that are being built on the waterfront there. Fascinating clients who are both Russian and Ukrainian, working together, trying to build this up, and they know that there'll be a future past this war, and they're thinking about what's next. This is a brand new research and innovation lab for Volvo in Sweden, literally just announced last week. And then a super interesting building that is under construction right now in Sydney, Australia. So this is for the tech company Atlassian. And before the pandemic, they were 70% remote to begin with. But they really understood how their company worked, and it was really about creating neighborhoods. And so they had a really tough site, but they wanted to make the most sustainable building they possibly could as a tower. But as you know, steel and concrete have heavy carbon footprints, and timber is really much better, but you can't build timber that tall. So this is a hybrid building where every 5th floor is a super floor of steel and concrete, and then a 5-story timber building is built on that floor, and it's in a park. So on the super floor, it's deep, so it has enough soil so that you can fully plant it, and then a 5-story timber building, then another super floor, 5-story timber building, another super floor, and you could see it go up from there. And the entire facade is jalousie windows that automatically open and close, so that you can, it responds to the wind direction, the temperature, the humidity, and keeps the park alive and a really great place to be. And then you work in the timber building inside the park, which breaks down the skyscraper into much smaller neighborhoods. And people can then, sort of get to know each other and work by groups and sort of have these smaller scale, more intimate places, even though they're in a 45-story building. So super tough because there's a train station on the left and there's a historic market hall on the right. So the whole building has to come down onto a very small core in the middle and cantilevers off of that. And then the X bracing is what gives it its rigidity from keeping it from torquing, so that the jalousie windows will work. This is under construction right now and should be finished in about 2 years. If Alberti says that sort of math is the place where art and science come together, I've always said that those three things create design, but that really there are all these other things you have to deal with as architects. And, you know, whether it's the politics or the finance or the theory or social responsibility or these kinds of technologies that we've been showing you that can help push it forward, that it's not just the aesthetics. It's really getting involved in all of these other elements. And that it's only when you filter design through those things that you get to architecture. That architecture has to take into account all of these other issues. And, you know, sometimes in school, they're like, you don't need to know about finance. You don't need to know about business. You don't need to know about, you know, I think in the last few years, I think that the social responsibility issues have really come to the forefront. And I think that's fantastic. And the sustainability issues. But you've got to get involved, and you've got to get involved in the politics of where you're building, in the technology of how it's being made, in the way it's being financed and underwritten. And as the architect, like what our great skill is that we can take all these disparate things and synthesize them into one thing. And if you try and pretend that you don't know that or that's somebody else's job, it weakens your design. And so it's really important to make a healthy practice to really think about all these things that are outside that we think of as outside architecture, but they absolutely are not. They are critical to know and understand. And, you know, don't get so nervous about knowing about finance. It's really like 60 vocabulary words and like knowing Excel pretty well. It's not that hard, but just, you know, you've got to at least sort of engage in it. So I'm going to just show 6 projects very quickly where we try to take all these things and brought them together. So thinking about meaning through context. So the first project I'll talk about is called the Brooklyn Tower. It's in downtown Brooklyn. It's on a triangular site, which is very unusual for New York. It has this beautiful historic bank on part of the site that we had to build around. And so you could see the interior of the bank, but it had been really badly managed by JP Morgan Chase. It was falling apart. So we committed to completely restoring it and opening it up to the public. And we looked at that triangular site, and the original architects used hexagons and 6-sided stars to deal with that triangular geometry of the building. And so we said, so the dark blue line is the landmark, and the light blue line is the interior landmark. And the rest of the site, which you could see in that very odd shape to the upper right, was where we could build a big slab tower as of right. But we went to the city and we said, look, if you let us demolish part of the landmark, we can build a much better building for the future. So the argument was to take that triangulation and bring it across the site, and then to build a tower that was a series of interlocking hexagons. And then to sort of think about each one in Manhattan, you sort of have the primary grid of the avenues and the secondary grid of the streets. But in Brooklyn, all the grids are different. And because we knew this would be the tallest building in Brooklyn, it's the only site zoned for this kind of height. We wanted to make sure that you always felt like you were looking at the front of the building. And so the hexagon, therefore, the hexagon shapes really helped us in sort of blurring that idea. And then we created a spiral with the setbacks as it went up. And we started to think about this notion of fluting, like what's fluting in nature? What is it in classical architecture? And what would a contemporary idea of fluting be? And we looked at this kind of color range from sort of like, we wanted something that was very somber. So it was sort of like very dark and strong black stainless steel up through brasses and bronze, and then even to a white ceramic. And we said, if we could create these sort of fluted elements that were taken from the historic parts of the bank and creates this texture on the hexagon, it would really change the way that you perceive the building. So we literally made, I don't know, about 2,000 different shapes from the bank, and different colors and different sizes and different scales. And we made these boxes, and we just made compositions of all the pieces coming together, and took light and photographed it so we would see what the sun would look like as it passed over this materiality. And it created this facade with these different textures on the building. And then we sort of mocked it up in a model here, and you could start to see what it would be like. And we were working on the interiors and taking the interior and bringing it up and moving the pilasters around to sort of catch the interior walls of the building. But I think the most important thing was that even though it's a residential building that also has 30% affordable housing in it, it has to have glass. But what we did not want was a large glassy building. I feel that when you're building these really tall buildings and they're just these taut glass facades, there's just a scalelessness to it that can never connect to people. And so we're really very dedicated to giving buildings texture and reading them at multiple scales, reading them at the neighborhood level, reading them at the street level, at the neighborhood level, and at the skyline level. And so what we wanted to do was take a building and make it not seem glassy. And so because you have a hexagon, you always have two facades that you're looking at in the oblique. And by getting the texture deep enough, you could see that the two facades you're looking at turn solid, even though they're glass when you're looking at the building. And so that became a really important part. We also had to connect to this historic bank, which is a spectacular building at the bottom. And so we thought about, because we had to demolish part of it, so we had to rebuild part of the facade, and we wanted to finish the whole block out in something that really related to the bank, and then the tower relates to the skyline. And so there were a lot of both convex and concave fluted columns on the site. So we said, well, what if we took concave at the top and convex at the bottom, and we lofted those two things together and created what we're calling the convexicave, which brings the two together as these 5-story pilasters. And what if we would CNC mill them out of solid marble? And what would that be? So this was the idea of what the new base would be with the convexicave pilasters. And then they're all bracketed. These are some of the details. So you see the top, how it's super convex, and at the bottom it's concave, and it's bracketed by these bronze elements, and how it turns the corner at certain areas. And then this would be how the base relates to the bank, and what you see as you come from Manhattan down Flatbush Avenue towards the Barclays Center, actually, which is up on the left. And then the other idea was to take the roof of the historic bank and turn that into the amenity spaces. So we put the pool around the dome of the historic building, so that when you're swimming in the pool, the historic dome comes up out of the water. And then created the bottom 2 floors of the tower coming in as the amenity spaces that connect to the outdoor space. So here you can see the pool and the dome. And then the model of the building sort of with the white base and the black tower. And then we used AR to bring this to the city. This is almost 10 years ago, so that they could see what the building would be like on site, and that how it would fit in as a neighbor, and how they could understand what the building was going to be. And so even though we were demolishing part of a historic building, they totally understood all of this, and they loved the convexicave columns, so which they gave us permission. And we even had unanimous approval from the community board, which never happens in New York, for sure. So here you can see the building as it started to go up. Here were the first installation of the facade panels. You could see the sort of almost Brunellesque kind of poche as it turns the corners. And then the different colors and materials, and because of the shapes, when the sun passes this, the building really is quite dynamic. Sometimes it looks very dark, and sometimes it's super bright and brassy and almost even orange, glowing with the sun. Here you can see, so when you're looking on the oblique, it looks like a completely different building than when you're looking at it from the frontal position. And here you can see it as it's nearing completion. We're getting very close to finishing it. The first residents have moved in the bottom half of the building, but the top half of the building is still under construction. And there you can see it relative to Lower Manhattan. And then the last part, of course, because they were hard to do, the convexicave columns are the last pieces going in. But here you can see them digitally milled, 5-axis milled out of solid marble as they're clipping on the base. And here you can see it turning the corner. And you can really see the texture and the shadow and this kind of crazy play of classical architecture and modern architecture simultaneously. And there you can see the building at night. Oftentimes we think about connections and about thinking about how do you work internationally. So we won a competition to do an innovation hub in Botswana, in Gaborone, the capital. And the two main features in Botswana are the dunes and the deltas. And so the idea was to sort of slice those up into onto the site to have both dunes and deltas. And there were these incredible existing trees. And instead of on the site, whether we wanted to maintain, so instead of digging out to make a basement, you have to cover your cars in Botswana. It's too hot. They can't be parked outside. So they build shade structures or they put them in basements usually. But we said, let's just build the parking on grade and let's berm the land up and let's leave the fantastic trees in place and build the building around the trees. And those would be the deltas, if you will. So there you can see that the tree stays in place. That's the parking underground. And then there's a new grade level that become these courtyards. And so this was the original image from the competition. And then we studied lots of different pattern making and basket weaving and other ways that people are using raw materials. We planted trees on the site while it was being built so that they could then be harvested and used on the interior walls of the building. And here was the sort of building as it floats above the grasslands, and also with the largest green roof in Africa. So here you can see the building under construction. They had some of the interior spaces, but it was really about modeling and how to. We brought laser cutters down to Botswana. We went into the schools and trained the students in how to use them, and then they ended up helping us build the building and helping us design and get the fabrication tickets made, but then even working with the contractors to put it together. So, for a lot of our buildings, we really model at a high level. So this is what we call the turntable, where we keep the active projects. But if you clicked on Botswana, you would see the level at which we model everything, because we break apart the building and send it to competitively bid the parts separately, but they're made like the best piece of IKEA furniture you could ever think of, that the parts just come back and we put it together. So, this is the level of detail that we go down to. So a fabricator doesn't know that they're making these parts for a skyscraper or car pipe assembly or whatever it might be. But we manage all this information, and therefore we can make any part completely. So it's all mass customization, where we can make any shape in any part, and it doesn't cost any more than just making a straight standardized part. And so this is the level of the detail that we do. We send that information out, they manufacture all the parts, and then it gets sent to Botswana, and we're able to easily put the pieces together without any skill, if you will, because it just bolts together like a part and gives you all the forms that you need that work performatively, that help us with solar gain and with other issues. So, anywhere you are in the world, you could build an incredibly sophisticated building. And the construction workers loved it, thought it was fantastic, and it was really great. So here you can see it as it was getting complete, and now as it's starting to finish. It was actually 6 different colors of copper on there, and we first got down there, they were trying to clean it to make them all the same. We were like, no, it's supposed to have 6 different colors. It's all good. But you could see the building as it got done. So this is where they have labs, and they're really investing in the future. Botswana knows it's going to run out of diamonds in about 40 years. So there's a phenomenal government program where they're converting the diamond wealth into innovation and research and technology and educating all the kids for free to try and, they want to kind of be the Switzerland of Africa, if you will. And this is the building that they're starting all of the, it's a 400,000 square foot building, but a 4 million square foot campus eventually that will be built there. But here you can see it as it got finished. So, I mean, the technology is great, but it's only in service of building, you know, good buildings and being efficient and taking care of them. And, you know, I always say one of the most sustainable things you can do, like photovoltaics are great, right? All this stuff is great, but the most sustainable thing you can do is build buildings that people love and they take care of them and they don't renovate them every 20 years. Like that's really the most sustainable thing that you can do. And be efficient in your design, use materials smartly, use good quality materials that age and patina gracefully, and you don't have to repaint it, you don't have to refinish it. That's the intelligence that really will have an impact on our carbon footprint. That along with living densely near mass transit. But this was a master plan that was done about 15 years ago to put 2 towers. I won't say the firm that did it, but they put the school on the southwest corner and they put the park on the northeast corner just to make sure that the park would be in the shade for its entire existence. And then they said that we had the right to build these 2 towers in this very tight envelope. So my client bought the site. This is JDS, Michael Stern, and said, this is pretty bad zoning. Like what could you do without having to rezone it, which is a very laborious process. So we said, look, let's look at that envelope and maybe we could just tweak the buildings so that it goes from one edge of the envelope to the other edge of the envelope and back to the other one. And then let's take that park, but let's make almost a second park for the residents and connect it with the bridge so that the whole amenities becomes this kind of middle zone in the building. And then let's put all the mechanical on one side and use the bridge as like an extension cord to plug into the other building and therefore have a almost free roof on the open roof on the top. And so then we sort of said, let's on the north and south, let's put a solid material, and on the east and west where you have different views, it would be these sort of thin glass elements connected by the bridge and tilt these buildings 4.5 degrees in each way. So the only trick about that is really the mechanical systems. And so we spent a huge amount of time modeling all of the mechanical systems and the plumbing, and that was really the trick of getting that building to work. So it's very standard apartments. Again, this building is also 20% affordable units. You could see as one building sort of moves north-south, the other building moves east-west, and then they're connected by the bridge in the middle. And then we skinned them in raw copper. So they came like a shiny brand new penny, and then they will patina over time, and they will eventually turn Statue of Liberty green at the end. Now, right now, they're sort of chocolatey brown, like kind of the way you think of a penny, you know, in circulation. Nobody knows how long it's going to take to get to Statue of Liberty green. We've asked every expert and everyone's told us anywhere between 15 and 50 years. So I'm trying to eat better because I want to live long enough to see them green. And it's just, they're maybe about 6 or 7 years old. And there's just a hint of a little bit of green now, but I don't know how long it's going to take. But if I'm long gone, go take a picture of it and remember this lecture. So here you can see the buildings as they got built. And then looking from the west towards the east on the river. And then the trickiest thing was building the bridge, because every part that the bridge is going into is leaning. So it's literally a shifted parallelogram in 2 dimensions to create the bridge. And then we said, well, what program should go on the bridge? And it was, again, very difficult to draw, very difficult to get the structure. There hadn't been a bridge built in New York in almost 50 years. And how to put that whole thing together, all racking in different angles. But then, you know, we got it together. You can see how it fits into the 2 sloping buildings on either side. And then we said, well, look, if we're going to put a program on the bridge, why don't we put the swimming pool so that you could swim from one skyscraper to the other, back and forth. And actually the funniest thing was the hardest thing to get approved in this project was the tile pattern on the pool bottom, because there's one guy in New York that approves all swimming pools. and he only likes like turquoise colored pools with thick black lines. And I think that was a 4-year argument to get that approved, but we did. And then this is on the 3rd level of the bridge, this is the lounge space. We actually have Kristen and Avaji here from Woods Baggett, who was the interior designer on all of this building. Here you can see the lobby, the copper panels as the building folds. And also it's in a floodplain, so we had to, the whole thing is resilient in the way that it gathers flood water and how you can pump it out, and all the mechanical systems are up on the 2nd floor. There's enough generators on the, like if there's a blackout in New York because of a weather issue, like you can kind of, if you have your phone and your refrigerator, you can kind of make it like a week, like no problem, right? What'd you say? Exactly. This was we designed this right after Sandy, and and so we put enough generators on the roof that every single apartment has a dedicated power line that even in a blackout will last for 2 weeks. And it connects to your refrigerator, and there's a special niche where you have this special plug so you can keep your phone going. So if you've got your phone in your refrigerator and the elevators are working, you can make it. Anyway, so you can see the buildings from the waterfront. That's looking from the Empire State Building and on the shore. When you think about a building in another city, we looked at Washington, D.C., and you know, it was DC is a tough city because it has small height limits and large blocks. So you end up with all these donut buildings, and there's not enough density to drive retail on the ground floor. And so it's kind of dead. And then you end up with these atria in the middle of the buildings that just are kind of soul sucking. And if your office is on that atrium, no one wants to sit there. And so they're kind of really tough buildings. So this was the old Washington Post headquarters, a kind of brutalist 60s building. It's right between like 3 subway stops, and like literally no one ever went here because it was so off-putting. So we said, what if we kind of rethought the way a Washington block went? We looked at, well, New Haven is the first planned town in the United States, but we looked at L'Enfant's plan with all the angles and the cuts, and we thought about them relative to like the quad on a college campus. And if we were in this building that was kind of in the center, what if we lifted the building up and allowed a quad to happen on the private property, invite the public in to cross and move through it? And this had never been done in Washington. And so the floor plan then became this whole series of 9 different restaurants. And the idea was to have it run by one operator that would be everything from like a taco stand to like a 3-star Michelin restaurant. So everywhere you could go, and then a bar up at the end of the courtyard. And there you could see the plan looking down. And so instead of making a 2 building, we made a U building facing south so that natural sunlight would come into that courtyard and everyone would be invited to cross the space. The facade itself also sort of took those angles and idea of the crossing elements. And this time we pre-patinaed the copper because I didn't feel like waiting. And so here you could see it as in green. And again, it helps with solar gain and orienting views. And then on the inside of the courtyard, it's just a minimalist glass wall. And then these were some of the exploratory drawings that we were doing about connecting those parts. Here you can see walking on the grade. There's we collect the rainwater in this area here. And then basically the client loved the building, but they said it's such a long walk to go around the U. Could you short circuit the U? And so the idea was that a 3-story atrium connects to a bridge that connects to a 3-story atrium that connects to a bridge that connects to a 3-story atrium that goes up. And then the bridges, you could walk inside the bridge or you could walk on top of the bridge. So there's actually 6 connection points between the 2. And that creates these bridges as you look in the courtyard. And you could see the building raised up and with all the F&B down below, and that you're invited into the site. And then this is looking sort of across at the offices Fannie Mae took 800,000 feet of the million square feet, and the CEO of Fannie Mae said, make me the nicest building that you can that I don't have to testify in front of Congress why I'm in this building. That's so good. So, but they love it. So here you can see the sort of cut throughs down at the grade, the plantings, the lobby, and the bridges. So we were doing this building around the same time we were working on another building, which was for Uber's headquarters. And it was also two buildings. And we also came up with the same idea of bridges, with double-decker bridges to connect the two. And the teams in the office got into a giant fight over which team came up with it first. And so here you can see Uber's headquarters. And you know what you don't realize in architecture is that you design a lot of buildings that never get built. And we were like, don't fight over it. Neither of them will probably get built, so it won't be a big deal, and we will never have to explain it. And both of them got built, and they still fight about it every day. Who came up with them? But Uber was a super interesting project down in Mission Bay near the new Warriors Arena. So there's this huge park system. So it was about linking into the park. We were thinking about the verticality of San Francisco versus, sort of the horizontality of a Washington. And so we said, well, what if you just flip the street grid vertically? And what if instead of taking the typical office components that are just laid out on a floor, what if we start moving them vertically and horizontally to open up space? And the CEO of Uber wanted to make it was a really smart idea. He wanted to make it so that you put the elevators in the back and make all the spaces where people come together linked in the front of the building and all connected by staircases. So it'd actually be inconvenient to take the elevator, but super convenient to walk up and down the stairs. And that when you were walking, he really was sort of, into this idea of walking and talking and solving problems, and all the conference rooms and all the meeting centers and all the collaboration centers and all the food are on these paths, and the sort of elevators are behind. And so it was really, the choice was what was the way to connect the most places in the shortest amount of time, drove it. So you see in the two volumes of the building, these are these kind of what we call the front porch space, and the white boxes are all the meeting rooms, and they're cantilevered into this space. And then the idea was to make it a kind of breathing building, so that none of that space was air conditioned and had a kind of second facade that opened and closed to make it natural space. And then we created these microclimates by embedding plantings into the facade itself. And so this probably explains it the most. If you look on the left, for like the front third of the building is not air conditioned or heated. So it was a huge savings on what the building would use from an energy perspective. And then the sort of back 2/3 are where all the programming is. And so that has to be air conditioned to allow the computers and everything to run. Fascinatingly, people love working in the unair conditioned space, not the air conditioned space. So here were some of the renderings. And then the idea was that the entire facade would be made up of bifold doors, 16 feet tall, made in bronze, and they're on worm drives, and there's sensors all over the building. And so it can read where the wind's coming from, the temperature, the humidity, and the building automatically responds to its environment. So this was the rendering of the building. Here it is under construction. Here it is when it's a chilly day and it's all closed. And then as it warms up during the day, the building begins to open up and breathe. And the rendering, all the collaboration spaces. And so like what's cool about it is when you look in the building, it's super, super low iron glass. So it's really transparent. You actually see everyone moving up and down inside the building. So the actual creative activity of being there becomes the kind of facade itself. And there you can see all the white boxes are the meeting rooms, and the doors opening and closing. And then it goes up to it all ends up on a park on the roof looking at the water. And you can view up into that space from the sidewalk. And there are the bridges. We don't know which team came up with them first. And here you can see as they go across from building to building. And some of those interior spaces. And there's like, I mean, this is when it just finished. They're throwing furniture everywhere because people really want to work in that space, not at their desks. It's super interesting. Now, the fascinating thing was it's a total breathing building. And so it opened in 2022. And everyone said, this is the greatest response to COVID we could ever imagine, an actual breathing building. I was like, we designed it in 2015, but okay, like, sounds good. But it actually is a really important thing, is buildings that breathe and buildings that respond to the climate and buildings that save, that really are attacking carbon footprint. And I'll finish with the very last project, which is 111 West 57th Street, which is one of the supertalls in New York. So a really challenging site, a really small site with a lot of FAR that we could put on the tower. And we kind of thought of the history of New York, of these kind of a fabric of low rise and then a fabric of towers, and to think about that history. And we thought about the buildings that New Yorkers love, the Woolworth building on the left, which happens to be where shops, offices are, 1 Wall Street, 30 Rock. They have this kind of proportion, this kind of elegance, this kind of, mass, this texture. Now, these were all office buildings, and they were all office buildings built before air conditioning. So the floor plates had to be small so that you could open the windows and get a cross breeze in. And that's why they have this kind of particular proportion. And it gives you a particular kind of skyline. Now, post-war, there are spectacular modernist buildings, international style buildings like the Seagram's building, many others that maybe are good or not so good, doesn't even matter. But the 30,000-foot floor plate becomes the standard with air conditioning and lighting for American sort of corporate efficiency. And that becomes the standard that everyone has to build. And that gives you this completely other kind of skyline. Again, not judging good or bad, it's just a different skyline. And what's fascinating is that in the last decade or so, there's been advances in technology in building these very tall, slender buildings. There are very few sites left to build in Manhattan. So it's very tough to get a whole block. So you're fitting these buildings in to use the available FAR in just a few places. And so there's this generation of half a dozen to a dozen of these super tall, super slender buildings that are being built. Now, why are they being built? The fascinating thing is that they're not offices. Like, no one ever could have thought of residential buildings having the money to build buildings this tall. But it's all about getting access to the view of Central Park, which is a closed system of getting that view. And to get outside of that system, you're able to go tall enough that you get that view. Now, the technology has always been there to build the buildings and they wouldn't fall over. The problem with the technology was in predicting the movement of the building. And that's where the real advances have been made, because a building has to move. A building that's stiff is super dangerous and you should run out of it. A building that's moving is safe. That's good, right? Think about taking an antenna on a car and bending it. Think about bending a plate of glass, right? You want to be on the antenna. But you don't want to be up there where it's uncomfortable that you feel the building moving. So it's all about being able to predict that movement that allows you to do it. So, people don't realize that the Chrysler building is 90 by 90 feet in the tower. The typical post-war building is more like 300 by 150 feet. And this site was only big enough to put a 60 by 80 foot tower on the site. So it had, again, a landmark building. This was the Steinway building, where Steinway pianos were sold for 100 years. Really beautiful building by Warren and Wetmore. And so my client bought this vacant lot and then bought the Steinway building and then bought all the unbuilt air rights from all the other buildings and brought it on top. So we could have just built a building like this that would have obliterated the kind of beautiful top of the Steinway Tower. But we went to the city again and we said, what if you let us build on the landmark, but we'll shift it back so it really celebrates this building. We'll restore it, and then we'll put the tower up from behind on top of the landmark. And they agreed to do that. They thought it was a great idea. And so you basically have a retail podium And then you've got a large amenity space that's basically vacant. And then the tower really starts above the historic building, if you will. And then we were thinking about the kind of idea, we wanted a building that was very clearly from New York. We wanted a building that couldn't have been placed on or grabbed from Singapore or London or LA or anywhere. And so we thought about the setbacks and the kind of setback on the skyscraper and the famous Hugh Ferris drawings that you see on the left. And, you know, this is the sort of historic way that people did the setbacks. The contemporary way that most people are doing it now is just folding the glass along the sky exposure plane. Think of Hudson Yards and all the blue glass buildings that are there. And we said, is there a both and solution? Could we do what we've been calling the feathered setback, where each pilaster, each smaller element that breaks down the facade of the building becomes a setback in itself that has the kind of beauty of the arc, but also has the DNA of the past. And basically the building is an H in concrete. So it's two mega shear walls on the outside and then connected by a core in the middle. That wall typically would be a very blank wall because it's up against the neighbors and people don't put money into that. But we said, no, that actually should be the more spectacular part of the building. So we developed these pilasters and drew these kind of flowing arcs. And we said, what if each pilaster were this kind of linear element that would shift back and forth as it went up, so that as the light hit it from the south, it would create this kind of relief pattern or moire of shadow and light. And we were using terracotta and bronze again on this facade. So this is sort of standing at 5th Avenue and 57th Street looking west. And that was the idea of what we thought the tower could look like with the light and shadow hitting the terracotta. And this would be the view from the park where it would have it's also got inset bronze facing the park that gives the tower some shape, but it's really on the east and west facades. And here you can see the terracotta pieces. So there are 26 different shapes of terracotta in 6 different colors of cream, all digitally fabricated and all placed according to not have it have a kind of monotone coloring, but to almost make it look like it's always been there. And then there's this kind of bronze filigree in between these elements that are almost this kind of sinewy texture between the two. And here you can see this was the mock-ups of the facade. And then the building under construction. You can see there are some punched windows and bathrooms and kitchens that go through it, but really it's a mega shear wall that's holding this building up on the east and west. And then it's super open on the north and south, where you have the view of Central Park or the view of Midtown Manhattan. So here you can see it under construction. You can see the terracotta as it goes in and out and the shadow patterns that it gets played on it. And here you can see, so just so you know, this is the most slender building in the world. So anything that's, the slenderness ratio is width to height. So anything that's more than 1 to 10 is considered slender and is very complicated to build. Anything that's more than 1 to 15 is considered exotic and is incredibly difficult to build. The most slender buildings in the world are in Hong Kong. They're typically about, some of them are up to 1 to 16, 1 to 17. I think there's one that's 1 to 18. This building is 1 to 24. So it completely shattered every record, and working with WSP to develop the structural system was a remarkable feat and incredibly difficult. But here you can see it under construction. The guy who had to walk out on that beam to get up to that crane was like the craziest job ever. But here you can see it next to the Plaza Hotel and Gordon Bunshaft's 9 West 57th Street on the left. And the texture as it goes up on the sides, and the building as it's finished. It's only 60 apartments in the whole building. And there you can see it connecting to the historic building below. And again, the sort of public space faces towards the park. The bedrooms face towards the city. It's your typical unit, are 4,800 square feet. And the view from your living room with the nicest front lawn you'll ever have, that you never have to cut the grass. We worked with Bill Sofield on the interiors, really did a magnificent job of sort of a kind of like, glamour of New York. All the lighting was based on the building, all the hardware. And maybe my favorite detail I've ever done as an architect, these are the door handles, cast in bronze, so that every time you open or close a door, you've got the whole building in your hand. Some of the apartments are duplexes. This is how they come. This is how they're finished. And they have, some of them have double height rooms. Interesting. There's only 7 of those. Interestingly, those are the ones that sold first. These are not affordable housing units. And then here you can see the building and how it looks today. So in conclusion, I think it's been a hard 4 years dealing with everything going on in the world and the things that we're dealing with, with construction, with financing, with politics have made it harder and harder to execute. But it's when architects have to really work harder and put their heads down and know that they can build buildings of better quality, buildings that people love, buildings that people want to take care of, as we said. Building density around mass transit is really this, and then like leave nature alone is really the best thing you can do. But if you build density and you build it of low quality and you don't make great spaces and you don't make equitable parks and schools and mass transit that connects it all, then it's a dystopian world. So I think that as we urbanize more and more, the human population, it's more and more on architects to take on that role of making great cities and great places for people to live, where they have the greatest opportunities, because you have people crossing each other and learning from each other and inspiring each other, and to try and dedicate a life towards making those things happen, I think is a very special opportunity. And that you've got to not just think of design as the beauty, but the beauty is bringing all those disparate things like technology and politics and social responsibility and finance all together to make something beautiful. Thank you very much.
All right, awesome. Thank you very much, Greg. Do you have time for a few questions?
Sure, no problem.
Okay. Well, we'll start here and then if you can hand it up.
Hi, my name is Francesca. I want to thank you for an incredible lecture, really compelling projects, and I think the overall message of the responsibility of architects and designers to create these spaces and better design. I'm wondering, with all that in mind, I as a designer and everyone in this room being designers, we want to create these spaces. So, and your firm has had a lot of success in creating these spaces and creating these designs. So how do you convince people that this is the way to go, with finance in mind and with materials in mind? They're all beautiful, and I'd like to one day have a hand in something like this. But I think that sometimes there are things that stand in our way. And so how do you get over those humps?
Yeah, it's a great question. Yeah, there's a lot of things that stand in our way, and literally every day you're battling for that, for doing better, for it not like people say, like, well, if you get involved in finance, it's all about maximizing the profit. No, it's about spending the money wisely, right? If you're about technology, oh, you're just having a formulaic answer that the data is going to give you an answer. No, it's about understanding the data and creating it and using the technology to get more out of every dollar spent, right? Getting involved in the politics is about convincing people, like, a lot of people, there's a lot of NIMBYism in the world. And, this project got approved in 4 months, right? I mean, that's insane. And the Brooklyn Tower project got approved in 1 day, like unheard of. And it was because of the narrative. And this is the most important thing. Like if like there's anything you guys need to know as architects, is it's not just about these, it's the narrative. Tell a story of what you're doing and why this building is going to perform in a particular way. Tell a story how it connects to the neighborhood, how it's going to enrich people's lives, how it's a smart way to use resources, how it's going to be a good neighbor, how it's going to have positive effects. And if you can get that story right, it actually inspires you every day because you have to make like 10,000 decisions as a designer, like go back to the story when you don't know which one to pick and go, oh no, this one, this is the right one. And when you can get your clients and the city and the neighborhood, the community and the bankers, they're always the hardest, on board, like you can get everyone moving in the right direction. And it's a huge part of what we do every day. So, having a little bit of a cheerleader background helps, I think, too. Like you're constantly cheering people on to do better in their life. Hi. So it's a great question. And look, when technologies are new, there's always going to be problems. You're always going to be solving things on the fly. So one of the things that we've been thinking about working on, it's one of the more recent things that is if you're building these incredible, if you're developing these incredibly sophisticated models for making these buildings, how do we take all that information and not just like throw it in a drawer or leave it on a hard drive somewhere? And so we're working on systems right now that these become live models that have all the information on how to take care of the building in them. And the idea that we would love to do, and this is the latest thing that we're working on, is like, how do you make the Bloomberg terminal for real estate? Like, how do you have the thing that everyone from the people who live, who occupy it or work there or whatever, to the people who own it, to the people that run it, to the people that finance it, the people who maintain it, all have a completely transparent system where they can tell everything about the building. And so it's putting sensors in places, it's using that live model, and it's having this ability to have this interaction. We're just starting to develop it right now, but you spend so much time. I mean, to do a building, it's hundreds of thousands of hours of intellectual labor that goes into it, and then it's built, and then like no one looks at the drawings again, really, until someone wants to move a wall or something like that. But like we're really thinking about that, like how do you have a responsibility after the building opens, and so that's definitely something that we're thinking about. It's a really weird thing when you're doing a building like this, when it's under construction, like, you're there and it's like your build, it was in your head. Like, I walk through these buildings 10 years before I actually walk through them, right? Like I can see them. And then the day it's done, you kind of like give the keys to the owner and then it's like not yours anymore. You're not really allowed to go there. It's a very bizarre feeling, right? But, and then they only call you when there's a problem. So like, I think there'd be like, you're putting so much, intellectual investment in making this information, like how do we make it live beyond the day that you hand the keys over and that we can all work on it together? So you're literally on what's the next major problem that people are trying to solve. Well, I mean, to be honest, it's very hard because that change, people don't like change. And so like the facilities management people are like, get worried, like, oh, if it's all automated, I won't have a job. Like, it's like, no, there'll be more jobs because we'll be taking better care of the buildings and you'll know things before things break, right? Like you'll understand it. So, it's the same thing with digital fabrication. Like when we started doing 3D printing and CNC cutting and plasma cutting and all that stuff 20 years ago, I mean, the contractors were impossible. They were like, don't tell me how to build a building. It's like, we're just showing you how to maybe do it faster and better. you know, and then eventually, like, I mean, I was even like watching the State of the, 20 years later, watching a State of the Union address, and the president brings up 3D printing, and I'm like, well, that's how far it's fallen, that even they talk about it. Like, it's like now everyone embraces it, but it took 2 decades to get everyone there. So the answer to your question is, it's hard. The best thing would be to have the people that run the building be in the design sessions. And if you could have this kind of transparency of information where you could track everything, like where was the part made? What was the labor that made that part? Like, how do we think about that? Where was it shipped from? Does it have to come from 8,000 miles away, or can we do it from 200 miles away? Like, all those things are super important, and being able to make that information transparent for all the players, I think is the next big step in architecture and design.
Hi, my name is Sang. First of all, thank you for sharing the glimpses of the process that involved in bringing these iconic buildings to life. And I'm curious on how, the processes of identifying opportunities with material experiments. I'm curious if these experiments come um, organically during the concept phases of projects, or are there specific research initiative in the firm, like regardless of project application?
I would say it's both, but I would say it's more organic. I think a lot of it is, like, hey, it's really complicated. Like, hey, we've never used this before. Let's try it, or let's learn about it, or let's experiment with it. And I think the research comes in the sense of, like on the porterhouse, the sizes of the panels were not it wasn't because we drew one that was right. We wanted to do a zinc building. I don't remember why we wanted to do zinc. So we found out, like, well, how is zinc made and what sizes are the panels? Like, we researched all of them. So like, what's the most efficient size? And we found out that most zinc is made in France, and most zinc is 1 meter by 3 meters is like the cheapest sheet of zinc. And so the entire project was designed around cutting out 1 panel, 2 panels, or 3 panels out of that piece of raw material. And that was how we got 97% efficiency use of our raw material. So that was a research part, but like the organic part was, hey, let's try zinc. We think it like might look cool. And we found out, it was environmentally not problematic, and it aged very, very well, and it had a kind of strength, and it doesn't have to be repainted and all those other things. And then that was how we started to play with that material. And I would say that's how any of the materials start. Like, we just do some research and we try and think about it. I will tell one story. So when we did American Copper and we were doing the presentation for the building, we said, well, we had the model and we showed it, and we were like, well, you could do it in, like painted metal. You could do it in raw metal. You could do it in painted metal. You could do it in zinc. You could do it in galvanized. You could do it in brass, and you could do it in, you could do it in brass. You could do it in bronze. You could do it in copper. And the client said, are you crazy, copper? What are you going to tell me? I could do it in gold. And the next slide we had was the building in gold. And we said, yeah, you could do it in gold. And he said, all right, we'll take the copper. And that was it. So it's just pushing the comfort level of the client and showing them the possibilities of different materials and what you could do and what the benefits would be. And, and then it's so funny because the building ended up being called the American Copper Building. And it ended up becoming the whole marketing for the building was out of the material we chose. And that whole marketing campaign and the fantastic interiors and the fantastic amenities. And even though it's in a kind of like not great neighborhood of the city, it's a little inconvenient, it's a little boring over there. It set all kinds of records for the rental prices. And, I truly believe it came out of the fact that it's copper. And the whole city gets to see a kind of performance art piece as it turns green over the coming decades.
Thank you.
You said that the most sustainable thing you could do is to design buildings that patina and age gracefully. I was wondering if you could elaborate on that philosophy a little bit more.
Sure. So buildings is one of the greatest users of energy and materials. I forget what the number is. It's something like 30 or 40%. And so, you know, the worst thing is to build a kind of mediocre building that every 10 or 20 years you have to do a gut renovation on. Like, that's an environmental disaster. But if you can build buildings that are smart or efficient and use good materials that you don't have to fix every 10 years, but maybe every 80 years, that's an environmental victory. So that's what we mean by that. There was a fascinating study. It's a little dated. I'd like to get it redone, but in 1980, the average American house was 1,900 square feet. And by 2000, it was 2,900 square feet, right? So it's a huge, huge growth in the size of a house. And there was a study done that if you had an unlimited budget and can put every sustainable technology on that 2,900 square foot house, every photovoltaic, everything you could think of, the net carbon footprint would be equated by making the house 50 feet smaller, 50 square feet smaller. So it just like the size of a closet, you know, like a master bedroom closet, right? Like, people don't realize the horrible thing is making all these giant buildings. That's an environmental disaster. So making smaller, efficient, fantastic, high-performing buildings with great materials that are taken care of and beloved, that's how you win. The technology is great too, but like, start there.
One last question if you have
Okay.
time.
Okay, sure. Hi.
Hello. Thank you so much for that fresh breath air. Can you answer 8 questions in 1 minute?
80
I
questions.
don't think
in
I
one?
even have 8 questions for you, but I have one. How soon after people get taken inside these climate control rooms do architects rethink about the outside?
What do you mean about the outside? Like,
Well, there we go. I mean, we're losing thought about the, outside. We're at least in your projects that you created these beautiful spaces inside with the bamboo, I believe, that they find that those spaces much better than, outside. And then if we start doing that, and I feel like, climate control rooms is where we're at, where we lose connection from the outside, and that will be more inside than outside.
I mean, I think the way we try to think of it is there's indoor and there's outdoor, and there's something that we call mid-door, which is the sort of threshold between those two. And one of the things that we've been battling for is allowing more mid-door spaces where the public can kind of come in the building and the people using the building can come out into the public. And it's that kind of breathing idea. And funny enough, the pandemic has really promoted this. Like, before the pandemic, it was really hard to convince your clients to do these spaces. And now the buildings that do have these sort of breathable spaces are the ones that people want to be in. I also think that a building doesn't end when it hits the ground, that a building has a responsibility far beyond the object of the building. And so we try to think about that and the public space around it and the way you approach it and the way it connects to mass transit and the way it connects to the environment is super important. So I think what you're getting is we are trying to blur that boundary between indoor and outdoor, or object building and landscape. And that's really, I think, the future of how we have to build.
All right, Greg, thank you so much again.
Thank you. Thanks very much.